Hello, this is going to be about image similarity search. We're going to be using a vision transformer and we're going to be using Qdrant. I've got the Qdrant Docker image running in the background. That's free to download. You just need to install Docker and you can fire up the Qdrant database, the vector database, which you need to then populate with a collection. Use that with the Qdrant client. So let me just run this. So we're going to run the client. It'll create the collection. That'll be an empty collection. You see something's just happened there. That's just the background information. He's just done a put on the collection because there was already a collection. I'm using recreate. That's why I used put. So then we're going to create a data set, load it. From that image, we're then going to specify which image we want to match. I've chosen this one randomly. So I downloaded from Kaggle the housing data set and I've thinned it out because it was taking, I don't know, 10 minutes or so just to process it and do the embeddings. And I've made a CSV file which goes with it. That's the metadata. Now that's really, really minimalist. You actually would want other fields there. So this is not entirely accurate, but it works. So once you understand the minimal concept, then you can take it from there. So did that actually run? I think it did. So what it's done is it's processed all of the images, put them into the vector database, and now we're going to look at the one that is most similar to image 180. So if we come across here, image or the JPEG 180, let's find it, was this one. As you can see, a lot, because these are from Rightmove, many images are actually internal. So this is good even just in its crude form at the moment because it's actually helping you. 442 is the most similar according to this. So 442, there we go. So these are actually quite small images, 224 by 150 pixels. That says 224 by 149. Don't ask me what the difference is, why there's a difference. This is from these images are from Kaggle, so I would have expected them to all been identical sizes, but don't worry. So we kind of know it's working because those buildings look similar, and it's not come up with like a bathroom shot. So let's go see if we can make it find a similar bedroom. So that's 114. So I've got a slight numbering error in my code which I need to sort out, but I'll just work with it for now. So 14, that's a bedroom or bed in what looks like a very large, spacious room. Fingers crossed it's going to find another bedroom. If it finds a house with a swimming pool and an exterior shot, then we'll know it's gone badly wrong. So with Qdrant, Qdrant is a vector database, and you may or may not have come across Qdrant. Pinecone is Weaviate, and there's a few others which are possibly more promoted. With Qdrant, you use IDs, vectors, and payloads. These three things are the things. So the IDs are basically the ID numbers. The vectors, you specify how many vectors you want to be dealing with. In here, we've gone for 384. The more vectors, obviously, the bigger the database, and it probably has some impact on speed, but also on accuracy. The payload is actually kind of the human readable part of it. So you'll always have the three things that you insert, the IDs, vectors, and payload. So you have to basically prepare each of those. So that's run, and the image that we started with will be a perfect match, score 1.0. That's because it's matched with itself. So the next image is ID 359. So you'll notice because I made an error with my metadata, so everything's out by 100. So the ID is, but maybe that's good because your ID is 359, your image is 459. You might not always have matching. I don't know. What was it? It was 459. So we're looking for a large bedroom. And there we go. I think it's also probably matching on kind of color schemes as well, but there we go. There's a large bedroom. So it's kind of matched on a white room interior with a bed. So let's just try one more. Let's do one with a lot of greenery. See what it comes up with. So 377. So yeah, I need to knock 100 off. I will fix that. I just wanted to catch your mind. Sometimes you come back to something the next day and then you can't remember what you've done. So the get embeddings function is the one that's actually doing most of the work. Um, the data set, typically, if you do a tutorial, the data set will be from Kaggle and it will be ready made for you. But I think one of the first things that you need to, or that I need to get familiar with and get into the habit of doing is actually creating your own data sets. So data set is basically one or more folders of photos, if we're talking about image similarity search, and then you have a metadata.json or a metadata.csv file, and that will, I'll show you that. Well, that's the metadata CSV file. So image ID, so it's all CS comma separated values. You can also do it with JSON, but let's just go back and just finish off. We'll just check this one. So 114 is the first image, JPEG 114. Did I change it? Is it run? 277. Perhaps I was too busy talking and I didn't see it through. The end is saving the vectors so that you won't have to create them next time you can load them. Some of this is so specific. I, I don't know about you, but I don't think I will ever memorize every command. There's just too many. But as long as you know the bits that you need to modify compared to, for instance, what is it called? The Google Colab, yeah. So as long as you can look at a Google Colab and you know how to modify it to suit your own needs, then I would say that's a success. So payload, I'm just listing three at random there, the first three, just to check that something's happened. Batching is basically when you've got a huge amount to process, you will then split your work up into batches. So JPEG 377, which was the one we were trying to match on. These are quite small. I think if I create my own data set, I might actually go for some slightly larger ones. Um, that's right. That's the one we're trying to match on. So, and what's it saying is the next closest? 150. Okay. Well, we've got a house and we've got some grass. I think this is so there we go. It's not a million miles away. I'm happy with that as a starting point. Straight away, you've managed to filter out. filter out the difference between the internal photos and the external photos. So that's a good starting point. I think it's probably paying too much attention to the colors, for instance, the sky, the grass, and the color of the building at the moment. But once you start populating your metadata, then you will be able to get more accurate results. What it will boil down to is whether you can actually extract the accurate metadata from the source. I'm not going to name popular property and real estate websites because that might get me in trouble. But if you know them, then you will need to then identify the selectors, and you'll need to extract that to go along with. So obviously, this is picking out a house with some green grass, and I think it looks. I wouldn't want to say whether that's. I think that looks like two semi-detached houses, and really, it's matched on the grass here, I think, and some. It's outdoors. That's about the best match it's done. So, but here we go. That's the starting point, and it's. I probably spent most of the day unpicking the tutorial, which was. Which one was it? Yeah, this one. This was based on. Yeah, it's not pretty. It was based on melanoma. So I've managed to successfully unpick how it works and switch from melanoma to image similarity search on property. So hopefully that's of interest and you can take it from there. So that's the same as the tutorial. That is where it starts getting different is here. So dataset equals load dataset. So I'm telling it to use my dataset. I've left split equal to train. Not sure if that's right or not. Dataset equals image. I'm confused by that because image doesn't match anything I've set. Yeah, but it's working. One other thing, it will cache. So Hugging Face dataset image folder. To get rid of that, it tells you you just need to do rm minus rf because that's actually a directory. So there's some caching going on, so you just need to be aware of that because that could mess your results up. Device, depending on what device you're on, you may or may not have CUDA. That just makes a decision for you. VITI image processor from pre-trained Facebook Dino. Those are both as per the tutorial. This one, so Qdrant examples, Qdrant 101 image data. I actually find this better because if you go to the Colab, you end up trying to run it in, yeah. This is actually nicer to copy and paste from. Let me just go make that a bit bigger. So this actually describes what it's doing far better than I will. So yeah, so change that to suit your data set. And as I say, your data set needs to be so I've got houses data set, which my Jupyter notebook is pointing to, and then I've got houses, and then I've got houses underscore metadata. So I'm pointing it at the houses data set. Which is the parent folder, which contains houses and houses underscore metadata.csv. I'll scroll past that. That's not nice to look at. Yeah, so the one other thing is you will need to I was under the impression that I would need to make this match the name of that, the column. So yeah, if anybody can comment on that, I'd be interested. Um, Images equals image. So image keeps getting passed around, but uh, it's working, but I don't fully understand it. So that's slightly frustrating. But um, batch image again, image. So there we go. Images equals image. Yeah, so I'm telling, so there, image equals data set. Data set. So it's taking it's using the key of image. I don't know how this works. I think it's something to do, I think this is probably part of load data set. Let's data set. See, this is where you have multiple fields in the metadata. So there it's got image, image ID, so on. Oh, image is there. So that's the image. Image is coming is the first. Okay, I don't know, but there it is. That's working. So let's just do one more, and we'll just do a random match on. Let's just see what 27 is. Oh, so that's like a bungalow. Well, let's just see if we get an outdoorsy image with lots of grass. I think once I get a larger data set and I add the extra metadata fields, this will be much more accurate. The great thing about this is that you can experiment with the Qdrant database just from a Docker image. So you can, if you don't make it persistent, then you can just turn it off, turn it on again, and you can start again. The yeah, the batch size of 300 images is woefully small as well. So, but for testing, it did the job. So no complaints. So 127, that was the bungalow. Let's see what else was found. JPEG 180. So look at 180. Oh, yeah. So I guess it looks vaguely the same, but that's probably a five bedroom semi-detached house, and that's probably a 2 bedroom bungalow. But I think it's probably going to be more accurate on insides, on internals. We saw it was accurate on the bedroom. So there we go. That's the code, and thanks for watching.